Okay, so in this video we are going to solve this quadratic inequality. We are going to write our answer in interval notation. Now the first thing that we have to do is we need to get this so that I have 0 on one side and everything else on the other side of this inequality. It's easiest if my leading coefficient is positive, so I'm going to move all of these things to the other side of the inequality. I'm going to do that using addition. So I'd add 3x to the third to both sides. I would subtract 3x squared from both sides. Subtract 11x from both sides. And subtract 6 from both sides. And then I'm going to just kind of lay this answer out down here. So that would give me x to the fourth plus 3x to the third minus 3x squared minus 11x minus 6 is less than or equal to 0. Now is left on the right side of that inequality. Okay, so now our job, in order to solve this polynomial, I first need to find out what makes it equal to 0. And then what we'll do is set up intervals and test to find those sections where it is less than 0. So we have to start by finding our zeros. It's an x to the fourth. I'm obviously not going to be able to factor that out. So I start by writing down my possible rational zeros. I'll do that up here at the top. So remember, do factors of the constant term on the end. So factors of 6 gives me plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. That's supposed to be divided by the factors of the leading coefficient, but that's just 1, so it's not going to change any of these. So here are my possible rational zeros. If I'm going without graphing, I just have to pick one and try it out. When I say try it out, I'm going to use synthetic division with my polynomial. If I get a remainder of 0 on the end, that means it's one of my zeros. Let's just pick one to start with. Let's say that I start with 2. Okay, I'm just picking one of them. Then inside I write down my leading coefficient, so I'd have a 1, a 3, negative 3 for my x squared, negative 11, negative 6. Drop the first number straight down and multiply. So 2 times 1 is 2. 3 plus 2 gives me 5. 2 times 5 is 10. Negative 3 plus 10 is 7. 2 times 7 is 14. Negative 11 plus 14 is 3. And 2 times 3 is 6. Hey, lucky day. I picked a good one to start with because 2 ends up being one of my zeros. Okay, we need to then carry on because this was an x to the fourth. Finding that 0 just drops it to x to the third, which we still probably wouldn't be able to factor. So we need to continue and we need to find zeros. Now notice what would I have left over. Again, we drop it by 1, so this would be an x to the third, and these are our coefficients. So I'd have 1x to the third, and then I have positive 5x squared, positive 7x plus 3. So this is my new polynomial. So as I'm going forward, I can actually narrow down my possible rational zeros because now I'm finding zeros of this polynomial. They would also be zeros of my original polynomial, but I'm working with a smaller set of numbers. So the possible rational zeros here are just factors of 3. So either positive or negative 3 or positive or negative 1. Okay, so I'm going to test and see what I come up with. Let's try 1. So I write down my coefficients. So I'd have 1, 5, 7, and 3. Bring down the first number and multiply. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 6 plus 7 is 13. And 1 times 13 is 13. Okay, 16 is not 0. So 1 is obviously not one of my zeros. What if I tried negative 1 instead? So I'm going to clear this out and change this to negative 1. Okay, so I'm doing same polynomial, just going to try negative 1 instead. So again, bring our numbers straight down. Negative 1 times 1 is negative 1, and 5 plus negative 1 is 4. Negative 1 times 4 is negative 4, and 7 minus 4, or 7 plus negative 4 is 3. Negative 1 times 3 is negative 3. Hey, look at that, I get a remainder of 0. So that tells me negative 1 is also a 0 of my polynomial. So I have 2 so far. I have 2, and I have negative 1. And now I'm down to, see, I was an x to the fourth. I found a 0, which dropped me to an x to the third polynomial. I found another, and that one dropped me to an x squared. So if I write down this polynomial, I would have 1x squared, positive 4, so plus 4x, and positive 3, so plus 3. This is my polynomial that I have left over. Let's just set that equal to 0 and solve it. Now we will go ahead and factor if it will factor. I look for factors of that last term 3 that add to equal the middle term 4, and 3 and 1 would work because 3 times 1 is 3, and 3 plus 1 is 4. Okay, I factored it, I set each of those factors equal to 0 and solve them to find my remaining zeros. Subtract 1, I get x is negative 1, there's another 0, and x is negative 3. So see, negative 1 happened twice, so that would be a 0 with multiplicity 2, just by chance. Okay, but my zeros, I'm going to write them up here. The zeros for this polynomial are, let's see, negative 3, we found down here, negative 1, and 2 was that first one we found. And again, it's degree 4, so there can be 4 zeros, but remember this negative 1 was multiplicity 2. It happened twice, so that gives us a total of 4. Now, if we were just trying to find the zeros of a polynomial, we would be done. But that's not what we're just trying to do. We're trying to solve an inequality. So we have to continue because it's not just exact values, it's going to be intervals, not just things that make the polynomial right here equal 0, but the things that make it less than or equal to 0. So what we do is we set up a number line and we put the zeros on that number line. So the ones we found, negative 3, negative 1, and 2, and you would want to put them in the proper order. Smallest numbers to the left, biggest numbers to the right. We're going to test a number on each of these intervals. So we have to test something that's less than negative 3, let's say negative 4. We're going to test something between negative 3 and negative 1, say negative 2. Something between negative 1 and 2, 0 is always a good one to use, and something bigger than 2. So let's say maybe 3. And what we're going to do is test them, meaning substitute them into this polynomial and see if the value is less than 0 and would be part of our answer. If it's greater than 0, then it's not going to work. You can do this by just taking the number negative 4, substituting it in here and evaluating. I like to use synthetic division because we know that you can use synthetic division to do the same thing. And I like to use it because it seems to go faster for me. So that's what I'm going to use. I'm going to take this polynomial I started with. So my leading coefficient was 1, and then I had 3, negative 3, negative 11, and negative 6. Okay, and what number I'm testing? I'm testing negative 4. So remember, this is exactly the same as if I put negative 4 in for x here. Going to give me the same answer. So if you prefer that way, that's fine. This is just the way I prefer, and it gives me some practice with my synthetic division. Okay, so I came up with 54. So again, what that means is if I were to plug negative 4 into this polynomial, the number would be 54. So then our goal was to test. So I came up with 54. Is that less than or equal to 0 like I wanted? No, 54 is greater than 0. So this is not part of my answer. That entire interval is out. Now let's test between negative 3 and negative 1. So we decided to do negative 2. So again, I'm going to use synthetic division, but you could take negative 2, plug it into your polynomial, you'd get the same thing. Okay, I'm just going to go ahead and do my synthetic division. Again, the one thing I like about this is it gives me some good practice with synthetic division. Okay, so here I come up with -4. So that means if I put -2 in this polynomial, my answer would be -4. What was I trying to see? I'm trying to see if it follows the rule here, less than or equal to 0. Is -4 less than or equal to 0? Absolutely is. So this section is a yes. Okay, this one was a no. That's part of my answer. Now let's try 0. So again, 0 you can just plug straight into the polynomial. You can do synthetic division, whichever way is more comfortable. 0 is actually pretty easy to plug in because everything with an x would be 0. But we can do it over here too. Okay, and I come up with -6. So again, what was I checking? I was checking to see if it's less than or equal to 0. Is -6 less than or equal to 0? Yes, it is. It absolutely is. So this section where 0 was is also a yes. It's part of my answer. I have one section left, the section greater than 2. We decided to test 3, and you could test any number in that interval actually. We're going to go with 3. Again, I'm going to use synthetic division, but you do still have the option, if you're more comfortable with it, of just taking 3 and substituting it into that polynomial. Okay, and my numbers are getting fairly large at this point, so I'm guessing that I'm going to be greater than 0. And I come up with 102 here. That's really ugly. 102 minus 6 gives me 96. So is 96 less than or equal to 0 like it wanted? No, it's definitely not. So this is definitely not part of my answer. So my answer is these two sections from -2 to -1 and then from -1 to 2. Now what we want to check and see is whether we're including this -1 and we just have one long interval, or if we're not including the -1 and we need to break it into 2 pieces. To decide that, and to decide what brackets to use with your interval notation, you go back and you look at your inequality sign here. It's less than or equal to. If it's an equal to, you're including your endpoints. So I'm going from -3 to 1, including both of those, and then going from, -1, and then going from -1 to 2, including both of those. Since -1 is included, we just really have one long interval from -3 to 2. So my answer would look like this with square brackets. Again, that's because I am including my endpoints. The answer is the interval from -3 to 2. And why did that happen? Why did I get 2 yeses right next to each other? Well, remember that -1 had multiplicity 2, and multiplicity and even multiplicity means it just touches and goes back. Okay, so it touched the graph, if it were graphed, would just touch at -1 and still stay below the x-axis in this case.